Wil jy seker maak dat jou boedelbeplanning, eiendomstransaksie of ander regswerk deur professionele kundiges hanteer word? Hurter Spies Prokureurs beskik oor uitstekende kundigheid wat die opstel van testamente en die hantering van boedels betref. Hurter Spies Prokureurs het ook bekendheid verwerf vir hulle sukses met litigasie oor jou burgerregte. Kliënte se unieke behoeftes word deeglik deur kundiges op elke terrein hanteer. Skakel Hurter Spies Prokureurs vandag nog vir 'n konsultasie by 012 941 9239 of stuur 'n e-pos aan admin@hurterspies.co.za. Dis 012 941 9239.
Je luistert naar Isak du Plessis op Nuuspod.
Jim Adams, you are formerly from NASA. You did some important work there. Just explain to our viewers what you did at NASA.
Yeah, so I did a lot of things at NASA, but the last two jobs I had, and the one job that I think was really the sweet spot of my career, I was the Deputy Director of Planetary Science at NASA. So that meant that all of the missions that left Earth to go to other destinations in our solar system reported to me. So the rovers on Mars, the probe to Pluto, the Juno at Jupiter, and Messenger at Mercury. It was a fantastic time in my career. We were making history almost every week. And then the last job I had at NASA, I got a promotion beyond that. And I was the Deputy Chief Technology Officer for the entire agency, developing the technologies that would help us to continue to explore the universe as well as move humans out beyond low Earth orbit.
So when we talk to you about space and specifically about Mars, you absolutely know what it's about.
I do, yeah, without trying to pat myself on the back too much, yeah.
Well, I'm doing the patting, you can relax. Jim, I want to talk to you about Mars. It's just over a week now into Perseverance Rover's Mars mission. We're getting stunning pictures from over there, thousands and thousands of pictures that are being stitched together and showing the most amazing images of what's going on there. What did we learn so far?
So you know, my scientist friends would all hesitate to draw conclusions yet, right? So right now, what the team is doing is checking out the rover, making sure everything's fine. It's running through some checks. It's, you know, they'll probably move it a few meters and then back a little bit. In about 2 months, so they do this very slowly because they want to make sure they know all of the idiosyncrasies of these machines, and they do have kind of their own personalities. So then in a couple of months, the rover will release the Ingenuity helicopter, and it will begin, it'll back away, and then that whole sequence will happen about deploying the helicopter, and they'll probably take a selfie together, which is kind of cool. And, you know, it's just an amazing time to be at Mars, right? You know, the UAE arrived, China arrived, the US arrived. It's getting to be a crowded place.
Tell us, where exactly is this rover at the moment, and what size of area, just for us to come to grips with it, what size of area it's covering at the moment?
Yeah, so it's in the pan of a very large lake that's now dry. And this lake would be about the size of a small city. But it enters, or it's landed in a region in the lake that is what we would call on Earth a river delta. Yeah. So, you know, a river flows in, and all the silt that it's carrying, when it gets into the lake, it settles out, and it creates these deposits called the delta. Well, it's a perfect place to look for ancient life. And we kind of want to know, did Mars ever have life existent on the surface. And we're not talking about little green men. We're mostly talking about microbes and that sort of thing, bacteria.
Yes.
But the cool thing about a river delta is the water that flowed there came from a very much more broad region. So, and then it gets all kind of condensed down and squeezed into this river and then deposited on this delta. And it's just basically there for us to explore now. And then what will happen is the rover will pick up bits of it. Once it finds something important, it'll pick up bits of it and cache it. That's put it inside of a tube and leave it on the surface there for a future mission to come pick up and hopefully bring back to Earth.
How big is this Perseverance rover?
Yeah, it's about the size of a Mini Cooper. So
okay, so it's quite big.
It is. It's a metric ton. It weighs a metric ton. It's about the size of a Mini Cooper. It's electric, so and it gets its electric power from a nuclear battery. So we don't use solar panels on the rover. The helicopter does, but not on the rover. And we expect it will last for a very long time.
So and the size of the camera, just to try and understand how big an image, how big an area it can cover.
Oh, well, it's some of the most high resolution imagery. I don't have that fact memorized, but it's the highest resolution imagery we could ever fly to Mars. And then the fact that we have now relay satellites in orbit over flying over Perseverance and Curiosity, for that matter, we can now relay much more data back to Earth than we could if we had to talk to Earth directly. And so what happens then is we get these images back, and then we can overlay them and look at them from different angles. And we can, as you used the word, stitch together these images to make just these absolutely stunning panoramas that we see. And I'm certain that the science team is analyzing that carefully to try and decide where they want the rover to go first, because it's, it's like it's a brand new world to be explored.
What do we know of Mars up to now?
Yeah. So we could do probably 2 hours just on Mars, on ancient Mars. But what we know about Mars is that there was once a lot of water. And the big question is, where did it all go? We think a lot of it has been deposited on the poles, and then each winter season, the poles get covered in an ice shell of carbon dioxide. So this ancient ice gets kind of protected by the carbon dioxide ice. And we know that there are at least some people theorize a lot of like ancient glaciers underneath the surface of Mars. So that's kind of an amazing fact. How did it get there? Why is it there? That sort of thing. The other important fact about Mars is like, okay, why did it lose its water? And it's only got an atmosphere that's 1% as dense as the Earth's atmosphere. Why is that? And what we believe happened is that Mars either never formed or lost its coherent magnetic field. The Earth is protected by a magnetic field. And so what happens is, if there's no magnetic field, then the solar wind comes along and blows off the top layer of the molecules in the atmosphere. And eventually it just keeps slicing off the top of the atmosphere at Mars. And eventually a lot of the gaseous molecules that were making the Mars atmosphere are just gone. They're just out in the solar system. And so that's a concern. It's a geophysical effect that we want to try and understand about Earth, because it helps us understand what the future of our planet might be by looking at the past of Mars.
Tell us more about the atmosphere, the magnetic field, radiation, the breathable air on Mars. How much do we know about that?
Well, we know quite a bit. Well, to start with, the atmosphere on Mars is mostly carbon dioxide, so you couldn't breathe it, or well, you could, but you would suffocate. So that would be bad. If you were to stand on the surface of Mars on the equator, an average day, the temperature extremes, the high for the day would be on the order of 20 degrees C, but at night it would get down to minus 100. So very hostile environment thermally. You can't breathe the atmosphere, hostile thermally. The fun fact is it's got less gravity, so it would be easier to walk around if you could walk around. Now I've forgotten the question.
I want to know more about the magnetic field, the thin atmosphere, and how it impacts possible life on Mars.
Yeah. So what happens is not only does the magnetic field at Earth shield our atmosphere from being sliced off by the solar wind, it also protects us from space radiation. And the fact that Mars doesn't have a global coherent magnetic field like Earth does allows that radiation all the way down to the surface. So we are concerned about sending humans down to the surface of Mars because of the radiation. On the other hand, it would be the radiation that we think that the radiation that a human would receive on the surface of Mars would be less than if they were orbiting, because they're protected by the surface of the planet in part. On the other hand, that radiation, that energy, could aid in the mutation of chemicals and organics, which might explain the emergence of microbes on the surface of Mars. Now, we haven't found any, but there's evidence to indicate that maybe there are microbes on the surface of Mars right now. And what we've seen these very thin, tenuous methane blooms, methane coming and going on Mars. Well, what makes methane? Geologic activity like volcanoes and earthquakes and crusts and mantles moving around deep within the Earth, that makes methane. But we haven't seen any of that on Mars. The other thing that makes methane is life. Life excretes, and at least on Earth, it excretes methane. You think about cows, right? Or humans even, we release methane. And so it's possible that the methane on Mars may have come from life that exists today. And why does it come and go? Well, we think that maybe there's colonies of microbes under the surface that when the temperatures get warm in the summer, they wake up and they start metabolizing and excreting methane. And then when it starts to cool off again, they go back to sleep and wait for the next warm season.
The other question that I want to ask from you is, if it is so difficult to have life on Mars, how will it be possible to accommodate humans for someone like Elon Musk's experiment to exist on Mars? Are they going to eat potatoes like which was the American movie about Mars?
Well, we have a long way to go before we could sustainably occupy Mars. There's a lot of technology that would have to be invented. We'd have to make some decisions about habitats and how we would live and work on Mars. How would we, as you've brought up, how would we grow food? How would we get food? Because, right now, every bit of food that the astronauts eat on the International Space Station, which is just 200 miles above the surface, was that like 440 kilometers or something like that, above the surface of the Earth, every bit of it has to be transported from the surface of the Earth to the International Space Station. It's an 8-month journey for a payload to get from the surface of the Earth to the surface of Mars. So that's just not practical. If you're going to try and keep a crew of 2 or 4 or 6 alive on the surface of Mars, there has to be some sort of sustainable solution. They can't take everything they need with them. And so that's what we call in situ resource utilization. And the first step of that is figuring out how to take the carbon dioxide on Mars and turn it into oxygen. Now, living on Mars is going to take a series of technology developments. The very first one, the tiniest first step, is really taking that carbon dioxide and pulling the oxygen out of it. With oxygen, you can make water, you can make rocket fuel, you can have breathable air. There's a lot of things you can do with oxygen. So on Perseverance, there's a payload called MOXIE, and it will be the first time we will have ever done that kind of chemical separation on another solar system body. And so we'll try it. It won't produce gallons or liters. It'll produce a small amount, but it will demonstrate that we can take the carbon dioxide in the air, pull it in, and separate it so that we can have pure oxygen on Mars.
Verkeersboetes behels meer as 'n klein ongerief met minimale gevolge. Jy kan 'n kriminele rekord kry of probleme teekom as jy jou rybewys of motorlisensie hernie en die metropolisie kan jou by padblokkades lastigval om die boetes te betaal. Fines for You vir minder moeite met verkeersboetes deur hul te monitor en vinnig, wetlik en effektief af te handel sodat jy nie die ongewenste gevolge hoef te dra nie. Ons spesialiseer in groot vlote en streef daarna om jou geld te bespaar. Kontak ons gerus op 011 867 7331 of besoek ons webtuiste by www.finesforyou.co.za.
Jim, how will a typical mission to Mars with the first humans look like? How will they plan something like that? Will it be 2 or 3 people going up to Mars, taking the chance to die there? Or how do they plan something like this?
So that really depends on who's planning the mission, doesn't it? And NASA, the idea of returning astronauts safely back to Earth is in our DNA. It's something that was in the original challenge from John F. Kennedy. And, the notion that we would send an astronaut to the moon and return them safely is just, it's the way we think. And the notion of sending an astronaut off to their death is just not a thing that we would plan for. We just wouldn't send human beings to the surface of another planet, doesn't matter if it's Moon or Mars, without a way of returning them. And that also requires a great deal of technology development. It's now defunct, but there was a group called Mars One that was based, I believe, in Scandinavia somewhere, that had selected 100 people to be considered for the first crew that would go to Mars and stay. And they had every expectation if they went, then they would die on Mars. But in the meantime, they would be pioneers for the waves of humans that might come behind them. It's a very visionary thought. I've had the chance to meet 3 of those people, One is and three of them are from South Africa. Those are the three I had the chance to meet.
Yes.
One is
I'm speaking to
Adriana
one of
Murray.
them this afternoon.
Yeah, Adriana Murray is very well spoken about this entire subject, and I have to respect that. You know, it's not the way I would plan the mission, but it has a vision. And you know, Elon Musk, he wants to take hundreds of people almost immediately. You know, I'm not saying it won't happen, because the man has done things that we all thought wouldn't happen. It may not happen on his schedule, but you know, it takes people with vision to accomplish great things. And I believe that without these kinds of people, the Adriana Murrays, the Mars Ones, the Elon Musks, the China is getting ready to land a rover on Mars. You know, without that kind of thing, humanity won't move forward. And I think the last bit of messaging that I would, you know, leave with your audiences is that space exploration is an opportunity for Earthlings to come together in the pursuit of peace. Because you do these very complicated things, these challenges, not so much to get a leg up on the other nation, but to cooperate so that all humanity understands the fundamental science questions. Where did we come from? Where are we going? And are we alone?
Jim, last question. I saw an American series, Space Force. That's probably a mock-up of Donald Trump's Space Force. But one of the scenes in one of the episodes is where this general, which is heading the mission, is being scolded because he sent an orange to one of the people in the International Space Station, and the calculated cost of this orange is something like $100,000. And I wanted to know from him, how can he justify such an expensive orange for someone in the International Space Station? And he said, well, if I can't send an orange to one of my men to make his day, even if it costs $100,000, then I don't want to be head of this mission anymore. Can you give us an idea of what type of money is going into a mission like exploring Mars?
What kind of money is going into? You broke up there, but I believe that was the question. What is the budget for Mars?
Yes.
Well, it is not cheap. I'll just be honest with you. So a rover mission to Mars is probably on the order of $1.5 billion, right? But what I want people to understand is that money does not go to Mars with the rover. That money stays on Earth, and it feeds an economy that employs people and puts food on the tables for families. It creates innovation and technology that then gets returned and used on Earth in a variety of amazing ways. And we could talk a whole nother episode about things called spin-offs. Did you know that the cloth covering over a football stadium, I believe it's in Durban, is actually the same fabric that was developed to go on the exterior of the Apollo spacesuits, because it was so well suited to stand the weather, the sun and the rain in the South African environment. They chose that because NASA had developed that particular fabric for to withstand the rigors of being on the moon. So, I mean, there's thousands of stories like that where these investments, anytime a nation tries to do just something bodacious, you end up with these things called spin-offs, investments that can make life better here on Earth right now. And so I don't feel bad about spending $1.5 billion on the rover on Mars. There's so many good reasons to have done that. And in my mind, it supports humanity here on Earth right now.
Jim Adams, thank you so much for sharing your knowledge with us. All the best there in America.
Thank you very much. I had a great time chatting with you.
Yes, thank you so much.
Powergate Training is jou een-stop opleidingsverskaffer in die mynbousektor. Ons is by Merceta en die mynbou kwalifikasie owerheid geakkrediteer en spesialiseer in mynbou, konstruksie en die kraan- en huisbedryf. Ons streef daarna om 'n bekwame werksmag op te lei in 1-tot-1 of groep sessies, alles onder een dak. Powergate Training, dis jou poort na die toekoms.